Hello student, welcome to New LJ Commerce College MOOC. I am Professor Vaibhav Shah, Associate Professor and Head of the department. The topic of today's video is Poisson distribution, Semester 5, Unit 1. Next question. A person has some car and the average demand of car per day is a 3. Find the probability that on any day not more than 2 cars are in a use. Now, what is the difference compared to previous video lecture? Here, average demand is given. In Poisson distribution, mean or average is equal to m. So here directly value of m is given. In previous session, we have value of p given, value of n given, and then we find out the m is equal to n into p. Now here value of m is not required to find out, directly value of m is given. M is equal to 3. We have to find out not more than 2 car in a use. Not more than 2, that means 2 or less than 2 car in a use. Here we have to apply Poisson distribution. Poisson distribution formula is Px is equal to e raised to minus m into m raised to x upon x factorial. We have to find out not more than 2 car in a use. Not more than 2, that means 2 or less than 2 car in a use. So x is a less than or equal to 2. So that means maybe 0 car in a use plus maybe 1 car in a use or maybe 2 car in a use. Not more than 2, that means we can use maximum 2 car in a use. So in the Poisson distribution, m equal to 3 and first we take x equal to 0. So e raised to minus 3 into 3 raised to 0 upon 0 factorial plus e raised to minus 3 into 3 raised to 1 upon 1 factorial plus e raised to minus 3 into 3 raised to 2 upon 2 factorial. In all three terms, we have e raised to minus 3. So we can take common. So e raised to minus 3 in bracket, anything raised to 0 is a 1, 0 factorial is a 1, 3 raised to 1 is a 3, 1 factorial is a 1, 3 square is a 9, 2 factorial is a 2. E raised to minus 3 value is given and e raised to minus 3 value is a 0.05. So 0.05 in bracket 1 plus 3 is a 4 plus 9 by 2 is a 4.5. So 0.05 into 8.5 is equal to 0.425. So probability of not more than 2 car in a use is a 0.425. Second sum, in a book, on an average, again average is given. Average is given, that means value of m is given. There are 6 misprint in a 10 pages. So 6 misprint out of 10 pages. So m equal to 6 upon 10 is equal to 0.6. Using Poisson distribution, find the number of page having more than two misprint. Okay, we have to apply Poisson distribution. Poisson distribution formula is a px is equal to e raised to minus m into m raised to x upon x factorial. Value of m is a 0.6. We have to find out the number of pages having more than two misprint. More than two. So that means we have to find out p of x greater than 2. More than 2, that means 3, 4, 5, 6, 7, 8 printing error. This value we cannot find out directly. So total probability is always 1. So we'll do 1 minus p of x less than or equal to 2. So is equal to 1 minus p of x less than or equal to 2, that means x equal to 0 plus p of x equal to 1 plus p of x equal to 2. So value of m is a 0.6. So e raised to minus 0.6 into 0.6 raised to 0 upon 0 factorial, e raised to minus 0.6 into 0.6. Now we take x equal to 1. So raised to 1 upon 1 factorial plus e raised to minus 0.6 into 0.6 raised to 2 upon 2 factorial. Here e raised to minus 0.6 we can take common. So is equal to 1 1 minus 1 1 minus e raised to minus 0.6 in bracket 1 plus 0.6 upon 1 is a 0.6 plus 0.6 square is a 0.36. 0.36 divided by 2 is a 0.18. E raised to minus 0.6 value is given, which is 0.5488. Let's we consider as a 0.55. So 0.55 into 1 plus 0.6 plus 0.8 is a 1.78. So is equal to 1 minus this multiplication is 0.979 is equal to 0.021. So this is your final answer. Thank you.